Who was Ibn al-Haytham? Born around 1,000 years ago in present-day Iraq, Al-Ḥasan ibn al-Haytham, known in the West by the Latinized form of his first name. Initially Alhazen and later Alhazen, was a pioneering scientific thinker who made important contributions to the understanding of vision, optics, and light. His methodology of investigation, in particular using experiment to verify theory, shows certain similarities to what later became known as the modern scientific method. Through his Book of Optics and its Latin translation, his ideas influenced European scholars including those of the European Renaissance. Today, many consider him a pivotal figure in the history of optics and the father of modern optics. Ibn al-Haytham was born during a creative period known as the Golden Age of Muslim civilization that saw many fascinating advances in science, technology, and medicine. In an area that spread from Spain to China, inspirational men and women of different faiths and cultures built upon knowledge of ancient civilizations, making discoveries that had a huge and often underappreciated impact on our world. Ibn al-Haytham, pioneering scientist. Ibn al-Haytham's work was remarkable for its emphasis on proof and evidence. He is known to have said, "If learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads." By this he meant it was essential to conduct experiments to test what is written rather than blindly accepting it as true. Ibn al-Haytham was born in the year 965 in Basra, and died in about 1040 in Cairo. He was one of the earliest scientists to study the characteristics of light and the mechanism process of vision. He sought experimental proof of his theories and ideas. During many years living in Egypt, 10 of which were spent under what we may now call protective custody, he composed one of his most celebrated works, the Kitab al-Manasir, whose title is commonly translated into English as Book of Optics but more properly has the broader meaning Book of Vision. Ibn al-Haytham made significant advances in optics, mathematics, and astronomy. His work on optics was characterized by a strong emphasis on carefully designed experiments to test theories and hypotheses. In that regard, he was following a procedure somewhat similar to the one modern scientists adhere to in their investigative research. Different views about how the process of vision could be explained had been in circulation for centuries, mainly among classical Greek thinkers. Some said rays came out of the eyes, while others thought something entered the eyes to represent an object. But it was the 11th century scientist Ibn al-Haytham who undertook a systematic critique of these ideas about vision in order to demonstrate by both reason and experiment that light was a crucial and independent part of the visual process. He thus concluded that vision would only take place when a light ray issued from a luminous source or was reflected from such a source before it entered the eye. Ibn al-Haytham is credited with explaining the nature of light and vision through using a dark chamber he called albeit al-Muslim, which has the Latin translation as the camera obscura, the device that forms the basis of photography. Out of the 96 books he is recorded to have written, only 55 are known to have survived. Those related to the subject of light included the light of the moon, the light of the stars, the rainbow, and the halo, spherical burning mirrors, parabolic burning mirrors, the burning sphere, the shape of the eclipse, the formation of shadows. Discourse on light, as well as his masterpiece, Book of Optics. Latin translations of some of his works are known to have influenced important medieval and European Renaissance thinkers like Roger Bacon, René Descartes, and Christian Huygens, who knew him as Alhazen. The crater Alhazen on the Moon is named in his honor, as is the asteroid 59239 Alhazen. Born in 965 in Basra, during the intellectual heyday of Muslim civilization. Invited to Egypt to help build a dam on the Nile. After a field visit, he declined to proceed with the project, causing him to end up in what we now call protective custody for 10 years. From his observations of light entering a dark room, he made major breakthroughs in understanding light and vision. His discoveries led him to make significant revision to ancient views about how our eyes see. Through his studies of earlier work by Galen and others, he gave names to several parts of the eye, such as the lens, the retina, and the cornea. He set new standards in experimental science and completed his great book of optics sometime around 1027. He died at the age of 74 in around the year 1040. His book of optics was translated into Latin and had a significant influence on many scientists of the Middle Ages, Renaissance, and Enlightenment. For example, the optics book Perspectiva was authored around 1275 by Erasmus Whitlow, who later was called Alhazen's ape when people realized he had largely copied al-Haytham's book of optics. Ibn al-Haytham was born after centuries of intense activity in mathematics, astronomy, optics, and other physical sciences. Although he was preceded by great pioneers such as Aristotle, Euclid, Ptolemy, Al-Kindi, Banu Musa, Thabit ibn Qurra, Ibrahim ibn Sinan, Alki, and Ibn Saul, his work was distinguishably novel. Ibn al-Haytham's world. Ibn al-Haytham stands out in this long list as the leading figure in both the science of light and science of vision because his work depended so heavily on experimentally based demonstrations. His work was important for two reasons. Ibn al-Haytham showed that a person saw an object by something entering the eye rather than leaving the eye. Before Ibn al-Haytham, both ideas had been put forward by other scientists and scholars writing in Greek, Latin, Arabic and other languages. Ibn al-Haytham used systematic experimentation in his work on optics. Ptolemy, working in the Greek-based culture of 2nd century Alexandria, had used a similar approach in his work on optics. However, Ibn al-Haytham's work was distinguishably novel. Ibn al-Haytham greatly benefited from being able to use the work of previous generations of scholars that had been translated into Arabic over a period of over 200-300 years under the patronage of various Muslim rulers and wealthy aristocrats. This included direct translation of many scientific works from Greek, Syriac and Persian, which themselves were the heirs to the great scientific traditions of ancient Egypt, Babylonia, India and China. In turn, Ibn al-Haytham's work proved to be equally influential on scholars writing in Latin during the Middle Ages and the Renaissance. In this way, he formed part of the intellectual legacy that Latin scholars derived from Muslim civilization from the 13th century onwards, including the Renaissance and early modern periods. With new scientific insights such as those of Ibn al-Haytham, as well as medical marvels, astronomical observations, new maps, libraries and advanced schools that taught various mathematical subjects, Muslim civilization made significant and crucial contribution to the accumulation of scientific knowledge in the pre-modern age that changed the ancient world. These past discoveries have shaped our homes, schools, hospitals, towns, the way we trade, travel, and our understanding of the universe. The dramatic story of Ibn al-Haytham's life. The story of Ibn al-Haytham's life and discoveries is truly extraordinary. Born in the year 965 in Basra, he made significant contributions to our understanding of both vision and light, bringing important new insights into both of these subjects. His brilliant breakthrough, however, came at a time of the darkest episode of his life. Ibn al-Haytham grew up at a time when schools and libraries flourished in the Muslim civilization. Students had access to highly trained scholars who could teach a variety of subjects, including law, literature, medicine, mathematics, geography, history, and art. Debates and discourses were popular and took place in Arabic. Scholars enjoyed discussing ideas from newly translated ancient manuscripts. Ibn al-Haytham's scholarly reputation spread well beyond Basra. He is known to have said, "If I would be given the chance, I would implement a solution to regulate the Nile flooding." This claim reached al-Hakim, the Fatimid caliph in Egypt, who invited him to Cairo. Confident of his own abilities, Ibn al-Haytham boasted that he would tame the great Nile River by building a dam and reservoir. But when he saw the extent of the challenge and the marvelous remains of ancient Egypt on the river banks, he reconsidered his own boast, thinking, if such a huge project could be done, he reasoned, it would have been done by the brilliant builders of the past who had left us such fantastic architectural relics. He returned to Cairo to inform the caliph that his solution was not possible. Knowing that the particular caliph did not entertain failure and that his life would be at risk if he were to disappoint him, Ibn al-Haytham feigned madness to avoid the caliph's wrath. He knew that Islamic law would protect a mad person from bearing responsibility for his failure. Despite the caliph's wild swings of mood, he nevertheless abided by Islamic law. Rather than executing or expelling Ibn al-Haytham from Cairo, the caliph decided to put the scholar under permanent protective custody. That was required by law in order to ensure his safety and that of others. Ibn al-Haytham was placed under what amounted to house arrest, far from the lively discourses and debates to which he was accustomed. Yet just as life was at its bleakest moment, Ibn al-Haytham might have made the dazzling discovery for which he is best remembered. Legend says, one day he saw light shining through a tiny pinhole into his darkened room, projecting an image of the world outside onto the opposite wall. Ibn al-Haytham realized that he was seeing images of objects outside that were lit by the sun. From repeated experiments he concluded that light rays travel in straight lines, and that vision is accomplished when these rays pass into our eyes. Ibn al-Haytham confirmed his discovery by experimenting with his dark room, translated into Latin as camera obscura, which simply means dark room. After many additional experiments using special apparatus of lenses and mirrors which he built, he laid down his new ideas about light and vision in his 7 volumes Book of Optics. He was released from prison on the death of the caliph. Ibn al-Haytham died at the age of 74 in 1040. His greatest work, the Book of Optics, had perhaps begun from the confines of imprisonment and was completed around the year 1027, but its impact rippled out across the whole world. Both his optical discoveries, and the fact that they had been validated using hands-on experiments, would influence those who came after him for centuries. So how did that influence shine its light on later generations? In the early 12th century, Toledo in Spain was the focus of a huge effort to translate Arabic books into Latin. Christian, Jewish and Muslim scholars flocked to the city, where they lived alongside one another and worked together to translate the old knowledge into Latin and then into other European languages. Ibn al-Haytham's Book of Optics as well as some of his other scientific works were translated into Latin, making them available to European scientists including Roger Bacon, Johannes Kepler and even Leonardo da Vinci. How Ibn al-Haytham changed the course of science. Ibn al-Haytham's discoveries in optics and vision overturned centuries of misunderstanding.